Following video is part of my practical TypeScript course. And if you wish to enroll in the full course, please navigate to codingaddict.io. Again, the URL is codingaddict.io, or you can utilize the link provided in the description. Okay, and while we're still on a topic of HTTP, let's also see how we can fetch data with TypeScript. Now, normally I use Axios library with React query, simply because the setup is super straightforward and React query is really good at inferring the types. But let's start nice and easy and cover the straight up fetch API first. And also keep in mind that in this example, we'll just log the result. So we won't set any state or display pretty much anything in the browser. We'll just check for correct results in developer tools. All of that is coming up. Just be patient and wait for the React part of the course. Now, also, you will need the URL. So in the README, I provided a URL back to my server where we can just fetch some random tours. We were using this one in my React course to basically build one of the projects. So this is totally up to you. If you want to use this URL, feel free to do so. If not, if you have some other URL, you can, of course, use that as well. And for now, we'll just simply set up a fetch function. We will log the result. We'll see the issue if we don't have any type. And then in the following video, we'll have a challenge where you'll have to set up the type and proper returns and all that cool stuff. So for now, let me just grab, I guess, the URL. So we're looking for this one over here. And we want to come up with a function. So in my case, I'm going to go with a sync function. Let's call this fetch data. It's going to be looking for URL. It will be a string over here for now. No returns. We just want to set up the try catch. Since we have a sync operation, it's always a good start. Now in here, let's go with a response. So this one will be equal to await fetch. We pass in the URL. So notice how we can right away start using fetch. And actually, we'll cover that in, I believe, 2-3 videos. How come we have access to this function without any issues and TypeScript doesn't complain. And fetch has this interesting setup where it doesn't treat, for example, 404 errors as errors. It only treats the network errors as errors. Basically, if you'll have 404 over here, it's not going to come up in the catch block. So we'll do a manual check where I'll say if response.ok is not set, well, then I'll throw my own error. Again, this is just an extra check we need to do with fetch. For example, you don't need to do that with Axios. So we'll go with throw new error. Then let's set up the template string. We'll go with HTTP error and the status here. Let's go with status, and we're going to set it equal to a variable. Let me access that. We're going to go with response.status. So now we're checking even if we'll have 404 error, it will actually trigger the error and we will return whatever we have in catch block. And now let's access the data. Again, we're looking for the array of objects. That's what we have here. And you can definitely see that if you navigate to this URL in the browser and we want to set up another await. Let's go with the response and JSON. Let's invoke that. And at the very end of the try block, let's go with the return data. Now in the catch block, let's right away construct the message. So I'm going to go with error message. And this one will be equal to ternary operator, where I'll check if the error is instance of error. Well, then I will set the error message variable equal to error.message, since I know that the property is going to be there. If not, then I'll just go with something generic. There was an error. Like so, let's set this one up and then let's log just so we can see what's happening. We're going to go with error message here. And then at the very end of the catch block, we want to return empty array. So if we're not able to get all of the tours, we'll return empty array. Now, I guess for now, let's just log what we have in the data, and let's invoke the fetch data. Fetch data, let's pass in the URL. If everything is correct in the console, we should see this array of objects. And if I go over here and mess with the URL, since I have this check over here, now the response is not going to be okay. And I can clearly see that over here. So we're nicely throwing the error as well. And this is going to be my error message. So this works. Now where's the issue? Well, let's go over here, set the tours away to tours. So now I'm essentially assigning this to some kind of variable, and notice something interesting. What is the type? Well, it's any, because TypeScript doesn't know what I'm getting back. So yeah, I was able to fetch data. I have access to it. I have no issues. But this is equal to type any. Now, why is that such an issue? Well, let's try doing this. Let's go with tours map. We know that we're iterating over, correct, our array, and we should have access to each and every object over there. But if I type tour, check it out. TypeScript immediately complains. It says, okay, I have no info on this. This is type any. So how am I supposed to know what is this tour? So we're not getting any suggestions. We're not getting auto completions, anything like that. So yeah, I can set this equal to tour any, and then go with tour.name. But I mean, this is not going to be sustainable in the long run. So yeah, I can nicely see everything in the browser's console. But since we're working with TypeScript, we will have to figure out how to provide the shape of our data to TypeScript. So TypeScript knows that, hey, listen, this tours is going to be an array of tours where I have following properties. So I have ID, name, info, and rest of them. And this is something that we're going to do in the next video as a challenge. All right. And once we see the issue, now let's fix it. How? Well, we're working with TypeScript. So we need to provide the shape and set up the correct return type for our fetch data. And once we do that, TypeScript is going to know what we have there. And then we'll have auto completion, suggestions, and all that cool stuff. So here's the challenge. Set up the type, a hint. You can use the URL as your reference. And also set up a proper return type for the fetch data. Again, a hint. Remember that it's a promise, correct? Because it's async. So first, let me navigate to the browser, and I can see that essentially each and every object is going to have ID, name, info, image, and price. And guess what? It's pretty straightforward. All of them are strings. So now I just want to navigate back to tutorial. And somewhere over here, set up my type. I'm going to go with type, and name is up to you. In my case, I'm going to go with tour. ID is going to be equal to string. Then I have the same for name, info, image, and price. So you know what? Let me just copy and paste. Hopefully it's going to be faster in the long run. So we have info here. Then we have image. And at the end, we also have the price. Let's save this. And there's two places where we want to set up this type. So first, we want to set it here where we have the return. And I'm also going to set it over here where I have the data. So I'm going to say that I'm expecting from this .json back my array. And it's going to be an array of tours. And the same over here for my fetch data. I'm going to go with my return. And remember, this is async, correct? So what do we need to pass in? A promise. Promise is what? It's a generic. So we go over here with tour, and then we pass here the array as well. Now, don't worry, if it's empty, it's still technically going to match whatever we have in our return. And now we don't want to set this as any, of course. We can actually go back and we'll nicely see that this is a tour. Why is that super beneficial? Because check it out. If I'm going to go here with log and tour dot, notice I have all of these properties right away. available. I can go with name, save it. Again, the result in the browser is not going to change, but essentially, this is just a type safe way how we can fetch data, where we come up with the type, we set up proper return, and after that, we can start using this data in a type safe way in our project. All right. And the moment we feel good about ourselves that we have nicely provided the type and everything is awesome, we can start using in our project. Let me throw you a mind grenade. So, what do you think is going to happen if I'm going to remove some properties or I'm going to add some extra ones? So, let's say if I'm going to go with something and then I'm going to set it equal to a Boolean. What do you think is going to happen? You think I'll have access to it? Do you think TypeScript is going to complain? And I guess you can clearly see that TypeScript is not complaining. And actually, if I go over here, technically I can even select it. But what is the result? I'm getting back undefined. So here's the kicker. Yes, this is definitely something we want to do. We do want to provide a correct shape to the TypeScript. But there's no way for TypeScript to check this at runtime. So yes, this is super useful for us to later use in our code. You saw previously what happens if we don't do that. Then basically TypeScript thinks it's any. But also, just because we set up this type over here at build time, it doesn't 100% guarantee that at runtime we'll get the correct results. Because this is just build time. In here, we're saying, yeah, this is going to be my shape. So I can type here whatever I want. And TypeScript is going to be like, hey, listen, you told me that this promise is going to return the array of tours. And this is going to be the shape for the tour. But what if the something is actually not there? I mean, there's no way for TypeScript to check that. And therefore, in the following video, we'll take a look how we can do the runtime checks with the help of extra library by the name of Zod. Okay, and up next, let's see how we can validate data at runtime. First off, let me just mention that technically you can do it manually. So in this case, yes, we can iterate over data, check if the specific property exists, as well as has the proper type. And even though it sounds super cute, in reality, it can get messy pretty fast. So instead, if you ever need to validate data in such a way, Zod library is a very solid choice, simply because it provides a bunch of options out of the box, and it's far better battle tested than our own validation code. Now, you can use Zod in other scenarios as well. For example, in my Next.js course, we use Zod to validate form submissions on the client, as well as server actions on the server. If you are interested in learning more about Zod, just visit zod.dev, or you can follow the link I left in the README. First thing we'll need to do is install the library. So I'm going to open up the terminal. Now I'm going to open a new window. Technically, you don't have to. Just make sure if you stop the server to start it up again. Otherwise, stuff is not going to work. So in this window, I simply want to run npm install and Zod. So now we install this library. And as a side note, in few videos, we're going to talk about declaration files. So there's another reason why I'm installing this library. So we install the library. Okay, everything's beautiful. I can close this window. There's really no need. Then we want to import Z from Zod, and essentially it's a named import. And then we want to construct our schema. So let's set this one up. And you know what? I can just type it scratch, I guess. So let me go over here. Let me go with import, then Z from, and I'm looking for my Zod library. Again, if you have successfully installed, it should be somewhere over here. Notice I have dependencies. And there I have the Zod one. So we import the Z, and then we want to construct our schema. So this is very similar to what we have over here. This is going to be shape of our data. But difference, well, we'll use Zod methods, and this is going to be checked at runtime. So I'm going to come up with Tor schema. And as a side note, eventually we'll set this equal to a different value, but not for now. So in here, we want to go with Z, and then the object is the method we're looking for. So I'm pretty much saying that I'm constructing an object. And here, yes, we pretty much want to provide the same properties. And as a side note, I think I can remove this something here and this one here as well for now. We'll figure out what we're going to do there in a second. And yes, we want to set up the validation for the same property. So this is not going to change. However, in this case, Zod provides a bunch of methods. Now, again, I'm not going to go through each and every method. In this case, we simply want to check whether this is going to be a string. And this is super easy. I can go with ID and then Z dot and then string. So this method essentially is going to check, is it a string or not? And if it's not a string, if it's not present, then basically it's going to yell. So now let's copy and paste, and we simply want to provide different values. So we're looking here for name. Then we want to get the info. We also want to set up an image over here. So image. Lastly, we also have the price. So all of them are strings, but the commas are missing over here. That's why I have the errors. So let me set this one up. And then as far as the Tor, we can actually infer the type. So I'm not going to leave this for your reference since you have access to it in a README. But essentially, I can go with type Tor, and instead of hard coding, Zod has this method of infer, and it is actually a generic. And we should be familiar with this one. So notice the syntax. Effectively, we just go over here with these angle brackets. And then inside of the angle brackets, as far as the type, we go with type of, and then Tor schema. So now we infer this Tor type. And notice pretty much the result is the same. But now we're nicely getting this from Tor schema. And like I said, you have more options. For example, ID has to be a string, but I can also add min, max, and all kinds of methods. Again, this is just scratching the surface. And notice how we don't need to change anything here in the return or also here in the data. But we do want to right now add some checks at runtime. And in order to do that, I'm going to rename this to raw data. So this is not something we're going to be passing. And instead, we want to go with const result is equal to. Then we go with our schema. It has an awesome method of array, which we can invoke. We're not going to pass anything in. And we also have this safe parse. So essentially, safe parse is not going to trigger automatically the catch block. We'll do it ourselves. So we're going to go with safe parse. We pass in our raw data. So now we're going to check this at runtime. Actually, not only at build time. And then since we have a safe parse, since this is not going to trigger immediate error, we want to check for the success property in the result. So if essentially we don't have the success property over there, then we'll go with throw new error. And let's again come up with some message. Let's go with invalid data, for example. Let's access the result dot, and we're looking for the error. So if we're not able to parse, then we'll throw the error manually. And now where we have the return instead of data, which we don't have anymore, we're going to go with result.data. So that's where our data is going to be located. And again, if we're successful, this doesn't change. We're still getting back that array, but the difference will actually check everything at runtime. So now let me navigate to the browser. I don't believe I'm doing anything. So you know what? Let me just log the result just so you can see what we're getting back. Let's go with the result. Notice we're successful. So success is true. So we bypass that error one, and then we get back the data over here. So now I can navigate to my map one. And again, I have access to the Tor. So let's log something. Let's go with tour dot, and again, let's access the name. So this works. Now here's the biggest difference. If I'm going to go over here and let's say add a property, which I'm expecting, but it's not there, we'll actually get the error. So if I'm going to go with something and set it equal to whatever number, it doesn't really matter. If I go over here, notice how immediately this is going to trigger the error. So success is equal to false. And now I have this error message in the console. And again, the cool thing is that we're checking this at the runtime, not just at build time. Okay, and I think at this point, we're ready to talk about TypeScript declaration files and why they're so important. And let's start with a small recap. If I were to go to tutorial, and you know what? No, let me create a file first. So I want to create types, yes, and here I'll right away export, and I'm going to go with export type and random. And here, let's just go with name and string. If I were to import this, so import, I mean, with the type keyword or without, everything is going to work, correct? Because TypeScript knows everything about this type random. So I can start right away using it in our project. So far, so good. But can you explain to me this? How come I right away have access to the document object? So if I type over here, press dot, I have access to all of the methods and all of the properties. And of course, I'm not going to double check that. So I'm not going to prove that it's definitely a document object. But trust me, it's the same one. And again, good luck trying to build something without this document object. So how come we have access to it? Because I can guarantee you that I didn't set it up anywhere. It's not like I went to the types and then started constructing the document type. I mean, that would be just a work for, I'm not sure, half a year. So what's happening over here? Well, you see, when we work with TypeScript, there's something called declaration files. And the same is going to work for libraries, something we're going to cover in a second. But when it comes to TypeScript, they get included. And then essentially, as we're working with TypeScript, it already knows everything about the document. So if we go here to a type definition, there is a definition for this document. Like I said, it's going to be giant. But good luck working without the document. So in here, there's an info about every property, every method, what it's doing, what parameters the function is expecting, and that sort of thing. So in here, technically, there is no functionality that's going to be running in this file, but there's going to be type definitions. Since when we work with TypeScript, TypeScript needs to know everything about the shape of our data. Otherwise, as you saw with the straight up JavaScript file, it's just going to complain. So I guess first I'll show you where the declaration files are located, and then I'll show you how we can add them or remove them from the project. Now, as a side note, since we're using the boilerplate Vite application, it's already done for us. But yes, if you're starting everything from scratch, you can add those things manually. For starters, if we navigate to a node modules and TypeScript, which is a package we're using, under the lib, notice this long list. Well, these are declaration files. Again, once you navigate over here, let me just find something. Maybe this one over here, right? Notice you have these type definitions. It's not like in here you have some kind of function that's running. No, but you have clear description of type definitions. So again, if you want to start using something from the DOM, you can only do it if there's a type definition for that something in one of the files. Again, you'll see in a second, if let's say we don't have access to these files, TypeScript is not going to know what is a document or any other web APIs. And the way we control that, let me just close the node modules. Again, it's already set up for us, but essentially you can do it over here in this lib. Notice this DOM. Essentially, in the lib, you specify the set of bundle library declaration files that describe the target runtime environment. And notice over here this DOM. Well, if we remove it, notice something interesting. Immediately, TypeScript is going to complain. Immediately, TypeScript is going to say, hey, listen, what document? I don't know what you're talking about. So essentially, we can either set it up ourselves or we need to have those type definitions. Without those type definitions, we won't be able to essentially successfully build our project. So let me just close this one and navigate back to tsconfig. Let me add the DOM since I do want to use it, since we're building for the web. And this leads me to the second point. Yes, the same works with any library you want to use in our project. Remember how in previous video, we were able to import Zod from the Zod library and we were good to go. So notice how, again, TypeScript is not complaining. And in fact, TypeScript knows everything that there is to know about the import. It knows the types it contains, it knows the methods, properties, and all that. How? Well, let's check it out. Again, we're navigating to node modules. I want to close this one. We are looking for a Zod in this case. And under the lib, guess what? Again, we have the type declaration files, and in there, we have type definition. And therefore, once we start using the library, TypeScript has no issues. It right away knows what the method is expecting, what is the interface, and all that. Which leads me to another point. Yes, if you're going to install a library, which doesn't have the declaration files, basically there are no type definitions, you won't be able to use it. Now, the good news is that there is a repo, which essentially contains the types for a bunch of libraries. But first, let me show you what happens if we install such library. What is the result? And again, this is just a random example. I'm going to use bcrypt.js, which is a password hashing library. And technically, this is optional. I mean, you don't have to follow along. I just want to showcase something. So let me go to a separate terminal window. Let me install it. Okay, I installed the package. Clearly see that it's in my dependencies. Okay, good. Let me remove all of this. I'm going to go with import bcrypt.js from, and I definitely have the library, but check it out. So essentially TypeScript is complaining. There is no declaration file. So same issue like we had with the straight up JavaScript file. And like I mentioned before, the solution is following. There is a repo which contains a bunch of types. And I left the link in the README, so let me try to navigate over here. And in this repo, under the types, you'll be able to most likely find the library you just installed because it contains like what? 7,802 entries. So essentially you have TypeScript types for all of these libraries. And the one that we're looking for in this case is bcrypt.js. Otherwise, we cannot use it in the project. And the way we install the types is following. So we go with npm install. We're going to go with save dev, then add types, and then bcrypt.js. So our specific library. Let me grab this line of code. And the moment we do that, TypeScript is going to know everything that there is to know about this bcrypt.js. So if I'm going to go over here, type dot, notice I have access to all of the methods the import provides. Hopefully it's clear why TypeScript declaration files are so important when we're building the TypeScript project. And with this in place, we can move on to the next topic. Okay, and up next, let's cover TypeScript config file, where, as the name already suggests, we can configure our TypeScript setup. Now, if I'm being totally honest, I actually find this topic super boring, and therefore I'm planning to cover only the properties which, in my opinion, are the most important ones. But if you are interested in specific property, or maybe you feel like a rebel and you want to explore all of them, feel free to utilize this link in the README. So this is the link that you're looking for. As you can see, it guides us back to the documentation, and you can start scrolling and you'll see that this is a giant file where pretty much you can find everything that there is to know about the tsconfig. Again, big picture, this is where we control our TypeScript configuration. I just want to mention that we have this include, and in here we point to where the TypeScript files are going to be located. So in our case, where it is, well, it's in the source. This is where we're setting up our project. Then we have compiler options. And let's start with the target one over here. And with this one, essentially, we control the output code. So we navigate to a TypeScript playground. Notice I have this export const and then the arrow function. Now, if my target is a JavaScript language version, which has the arrow function already, then as you can see, the output code is going to be pretty much the same. But if, let's say, I change this to ES3, notice how it didn't have the arrow function. And therefore, we get good old regular function. So this is what we control over here in the target. Now, as far as the module, remember, with this one, we're controlling what kind of module syntax. Again, we're going to get back in the output code in the lib. This is where we were controlling the declaration files that we're getting. And pretty much after that, the one that we're interested in is the strict one. So this is this flag, which controls how a bunch of the errors and the warnings are treated. So if we're going to go with false, then a bunch of the things that technically should fail are not going to, and we'll be able to build the project. Now, if we set this one to true, then we have the strict type checking set to true. And then, for example, we have this no unused locals. So if I were to go to tutorial and come up with let something is equal to something, notice how I get this warning that something is declared, but I'm not using it. Well, if we go here and set it equal to false or just remove it, then essentially we'll have no warning message anymore. Again, just a example of one of the properties that we can use. This concludes the tsconfig, and with this in place, we can move on to the next topic.